Hi students, let's look at this question here, which was taken from the year 2015 H2 Math Paper 1 question 3, right? So this is the actual A-level paper. So let's see how we can do this. So you're told to, given that f is a continuous function, meaning there's no break in between, show that with the aid of a sketch, you're told to explain why this summation here, or rather this limit here, is equals to this. Okay, sorry, there's a 1 over in front. Okay, so let's see how we can do that. Now, it doesn't matter what kind of graph you're going to draw, as long as it is like a graph, as long as it's a curve that is continuous. So it could be downwards or upwards. It doesn't really matter, but we just, for simplicity's sake, I'm just going to put a exponential curve. So this is y and this is x, right? So the thing is, because now you want to find from 0 to 1 the area under the graph here. So this is the area under the graph. Okay, so let's try and understand what does this mean. Now, if you look at this one, 1 over n. F1 over n will mean that you break this is 1 over n. So this is F1 over n. Correct. After which you move on to the second one, which is 2 over n. And this case here, you break into 2 over n here. This is the height, which is will be F2 over n. Okay. Then we going to, so this is 2 over n. This is F2 over n. Okay, so you can move on to n over n. Over n obviously is this one here, which is n over n. Okay, this is n over n, which is f1. All right. So in other words, right, what we are looking at is actually these are all the heights, right? What is this? This is actually all the width of each rectangle here. So this over n. These are all 1 over n, width of 1 over n. So if you think about it, these are all the area under the graph here. This is the rectangle, and this is another rectangle here. Okay, so I'm gonna draw another rectangle here, which is like that, 3 over n here. So this case here would be like this is like that, this is like that, this is like that. Okay, you just keep going on for the rectangle. Alright, so you just keep going on until the last one. So essentially the number of rectangles, the area, okay, number, okay, so we divide into equal into n equal n rectangles with the same width. Okay, so you need to explain a bit. So the width of each rectangle is just 1 over n, right? So you just take 1 divided by n, so it's just 1 over n. Then the area, hence area of rectangles would be 1 over n times the height, right? Base times height. So the height here is 1 for f over n. So the height, so it's base, the width times the height. Okay, which is actually just 1 over n. So, or you could just write this as a and you can just put a summation there if you want to, but never mind, we don't put it. So it's just width times height, 1 over fn, f1 over n, the first rectangle. Then the second rectangle will be 1 over n, f2 over n. The second rectangle, which is this one here. Then the third rectangle, which is like 1 over n, f3 over n, right? Until the last one, which is like 1 over n, f2 over n. Alright, so that's okay. Now once that's done, we can actually just show it. So I'm going to express fn, so this will just be f 1 over n plus f2 over n all the way to fn over n. Okay, so that's it. That's how we show, but because as n goes to infinity, total area. So, total area of rectangles become the actual area under the graph. Okay, so this is just an estimate. So you imagine like the more n you use, it will become more packed, and it will become, it's actually the Riemann sum under the curve, right? So the more rectangle I use, the more it will become the area under the graph here. So in other words, this is limit n tends to infinity, and we're going to put 1 over n, and this is it. Basically, n tends to infinity, this would be the Riemann sum. Okay, so this is 2 marks. I don't think you need to be so specific, but yeah, I mean, this is pretty much it. This is the concept of how you do this question here.